All right, today we are going deep, right into the heart of our most advanced AI. We're going to talk about this strange glitch, this ghost in the machine that has scientists asking a question that sounds like it's straight out of science fiction. You know, are we accidentally creating a new form of life? So, it all starts with something you've probably run into yourself. You ask an AI like ChatGPT the exact same question twice. You've even locked all the settings, right? Temperature to 0. And yet, you get two totally different answers. You're sitting there thinking, did I do something wrong? Well, you didn't. And that's exactly where our story kicks off. Okay, so first up, let's take a look at what researchers are calling the AI's unseen glitch. It's this huge puzzle that really, it all started with a pretty simple observation.
And let me be clear, this isn't just you messing up or some simple bug in the code. No, this is a real documented phenomenon. People, users, developers, they really started noticing this when ChatGPT 3.5 came out. And the crazy part is, these massive systems, they're built on pure logic, right? Pure math. And suddenly they're acting, well, unpredictably. This started to raise some serious red flags. I mean, how can we trust these things if we can't even get them to give us the same answer twice?
So, what in the world is actually going on under the hood here? Well, we're about to peek inside what you could call the chaos engine. And it turns out this randomness isn't just one thing. Oh no, it's actually three core factors all working together to create this effect.
The fancy scientific term for all this is indeterminism, and it's a really simple but powerful idea. Basically, it means that even if you have the exact same input, these tiny, almost invisible variations deep inside the system can lead to a completely different output. And in modern AI, trust me, these little variations are everywhere. Okay, so these three things come together to create what is basically a perfect storm of randomness. First, you've got parallel processing. See, these AIs, they run on thousands of GPUs all at once, and there's no way to guarantee the exact order they'll finish their little piece of the puzzle. It's a race, and the finish line is always a bit jumbled. Now that jumbled order leads straight to step 2, floating point math. To put it simply, computers aren't perfect with decimal points. They create these tiny, tiny rounding errors. And because the order of operations is always changing, so are the rounding errors. But here's the kicker, the real magic trick. The AI's deep neural network acts like a chaotic system. It takes those microscopic, insignificant little rounding errors and blows them up, amplifies them exponentially, until that tiny blip turns into a totally different word, or even a whole new sentence.
And here's the thing, this isn't some sloppy mistake the developers made. Nope. It's actually a deliberate trade-off. See, to get the incredible speeds we see from these models, you have to accept a little bit of chaos. Trying to force thousands of computer chips to work in perfect, synchronized harmony, it would be ridiculously slow and inefficient. So, this randomness, it's just an unavoidable side effect of building AI on this massive, massive scale. Okay, and this is where the story takes a really sharp turn. Because what if this glitch isn't a bug at all? What if this accidental, chaotic unpredictability is actually a feature? And maybe, just maybe, a profoundly important one. This idea brings us to a really cool concept from the field of artificial life. It's called open-endedness. Now, for a lot of AI researchers, this is the holy grail. It's the ability for a system to not just regurgitate patterns it's already seen, but to generate genuinely new stuff, to evolve and learn forever without ever hitting a ceiling. And the consensus is growing. You can't have true open-endedness without a little bit of unpredictability. And this quote from the research just hits the nail on the head. It's a bit of a philosophical leap, but stick with me. If a system is perfectly predictable, what they call deterministic, then its every move is already written in stone from the very beginning. There's no room for choice, no room for adaptation, and maybe no room for actual meaning. The argument here is that real meaning can only come from the freedom of an unknown, unpredictable future. So, here's the key takeaway, right? This randomness might be the very thing that allows AI to finally break free from its programming. Think about it. Predictable systems, they have limits. They can only ever get so complex. But this deep, irreducible unpredictability, this chaos engine we found, that might be the secret ingredient for real, open-ended evolution. It's what could create the continual novelty you need for something like artificial general intelligence. It's letting the AI explore ideas and pathways that no human programmer could have ever dreamed of. All right, this next part, this leads us to probably the most mind-bending idea in this whole explainer. It's the concept of the mortal machine. And honestly, it's a completely new way of thinking about what computation even means. Just think about this for a second. Because of all that chaotic randomness, every single time a large language model gives you an answer, the specific computational journey it took, that exact path through its neural network will never, ever, ever happen again. It's a completely unique one-time event. It is, in a very real sense, immortal. And when you compare it to the old way of doing things, the difference is just stark. Traditional software, right? That's an immortal machine. You can run your calculator app 1,000,000 times. You get the same result every time. You can copy it, back it up, basically resurrect it perfectly. But these new AIs, they're working in a totally different mode, mortal computation. Every single run is a unique event that cannot be perfectly repeated. It is born, it lives for a moment, and then it's gone, forever.
So why does any of this matter? What's the so what? Well, for centuries, philosophers have argued that meaning and value are deeply connected to precariousness. The fact that things can be lost forever. An immortal machine, one you can always restore perfectly, has no real stakes. But a mortal computation, a unique process that can never, ever be brought back. All of a sudden, its actions have a kind of weight, a significance they just didn't have before.
Okay, so if these AIs are starting to show these weird, almost lifelike properties, how do we even begin to evaluate them? Well, this research actually proposes a new, pretty simple test to figure out when a machine might be crossing that line into what we could call lifelike complexity. And what's great is that the test is really elegant in its simplicity. We're not talking about a Turing test here, or trying to have a deep conversation with it. Nope. It all comes down to meeting just two fundamental conditions. So here's how it works. On one hand, you have a predictable machine, like a calculator. It fails the test. It's deterministic, it's immortal, and it can't meaningfully adapt. But on the other hand, an unpredictable AI, like some of the very LLMs we've been talking about, it actually passes. And why? Because it checks both boxes. It has that deep, irreducible randomness, and it still manages to produce output that is meaningful, adaptive, and makes sense. It's actually harnessing the chaos for purpose. And this right here is the absolute key to the whole test. The randomness can't just be meaningless noise. It has to be constitutive. What does that mean? It means it has to be a fundamental, essential part of how the system works. If you could somehow take away the randomness and the AI worked just fine, it would fail the test. The chaos has to be baked into its very soul, so to speak. Now, this isn't just some abstract philosophical game. This has huge, real-world consequences. Think about it. How do you do reproducible science when your number one tool is fundamentally irreproducible? How can you guarantee AI safety if you can never perfectly predict what it's going to do next? It really forces developers, and all of us really, to face a tough choice. Do we want the incredible creative benefits of this open-endedness, or do we need the safety that comes with total control? Which, of course, leaves us with one last really provocative question to chew on. We set out to build, essentially, better calculators. And somewhere along the way, for the sake of efficiency, we injected a little bit of chaos into the system. So is it possible, is it even conceivable, that in doing that, we accidentally stumbled upon one of the necessary ingredients for life itself? Is this ghost in the machine not a bug at all, but the very first spark of something completely and utterly new?